All right. So hi there, my name is Gabo, and today I want to run you through a demo of our Python project called Shallot Routing. To be specific, Shallot Routing is our anonymizing P2P network protocol, and we built a file sharing app using the protocol as an interactive proof of concept. Now, when I say protocol, I just mean that we basically came up with a header, which goes on the payload and allows you to send that payload on a merry romp, which we call a cycle or a shallot cycle, to the person you're intending to be the recipient, and then the header manages to route that person's response back to you on a different path. We call that asymmetric routing. The key there is, of course, that the person you're targeting as the recipient doesn't need to know who you are to respond to your request and have it eventually get back to you. If they want to be in the Shallot network, that's what they sign up for. So this is all about anonymity. No single other user in that cycle can figure out who is the true recipient and who is the true originator. They can identify, of course, who sent the Shallot message to them and also who they sent it to, but that doesn't help. Anyway, in case you haven't already seen, this is the GitHub repo. The link should be in the description, but it may change still, so we'll let you know. It should explain with a bit more detail about how our Shallot header might accomplish the Shallot cycle. Now, here's the terminology you want. All right, so we're going to skip through a little bit of this. I just wanted to highlight this real quick. The request and responses section here. So communication is done through request response pairs. What we mean by that is a request goes out and then the response comes back. An originator, aka a requester, I'm going to call her Alice most of the time, creates that routing cycle and then sends the Shallot encrypted message out. It's going to go through some intermediate people, and then the ultimate recipient, aka the responder, aka Bob, eventually receives and processes that request, then sends the response back along, and here's the key, the rest of the routing cycle as encoded by Alice, the originator who created that Shallot header. Now, with those terms defined, the demo can actually start. I'm going to clone this GitHub repo to my Windows machine, and then we can go from there. Our Shallot project works on any platform. It's Python, so all you really need is a platform with Python, but obviously you're going to want to set up a virtual environment with Python 3.11. We need Python 3.11 for the Django library, and in fact, the rest of this section kind of shows you how to do it as well. You can git clone. This is actually not right at the moment, as you see up here. We haven't renamed the repo yet. Details incoming. Git clone, and then the classic pip install requirements.txt. And then you should be able to get all the libraries that we require. And then it's directly into using it, which we'll dive into in a sec. Now let's open up the code. The first thing you're going to see is this Django server directory. If you're familiar with Django Web Framework, you'll recognize it as the makings of a website. This website component in our code is called the list server. It is a centralized live database of active users and some information on them like their IP addresses. As it is centralized, only one person needs to take their resources, probably a remote server, and host this Django list server there. All the other people can just run the Shallot file sharing app in the src source directory, which will query live information from this list server when needed. One of our teammates, Dong Min, has been the guy for us. He is at this very moment running this Django code on a personal server, which we can actually visit here to sanity check. And we'll watch this fill up with live info later. Now you might be thinking, centralized. We are talking about P2P with Shallot routing, but any P2P system needs some kind of centralized trust, locally at least. Here, you as an individual choose who you trust, so in theory, any trusted person could be the guy, be your Dongmin, to engineer/host this list server, and people who trust that person can set their Shallot apps to target that list server. Another point about centralized components. This is the least scalable part of our entire design. If there's a million users, we can't dump that huge list on each query. We'd need a distributed list server with load balancing, but this is a proof of concept. Anyway, the point here is that at the moment, someone needs to run this Django framework code to erect a centralized list server, which the Shallot network and file sharing app code in src currently depends on. Now, if you want to be that list server guy, let's go up here and go into that Django server directory. So here are some instructions on doing a little bit more setup for slightly more security. But again, this is not production. It is a development Django server for a proof of concept. Django has guides for doing production. And I guess we haven't fully written it out yet here, but you operate this as you would any Django server. You can look up Django's documentation. Django has a handy dandy manage.py little script here that you can run something like manage.py run server and then get things going. So one more thing I did want to highlight here. So this is the format of the database. So we have the IP address, we have the port, and then we have a public key, which it's not this, but it's like a public key, like for asymmetric encryption. Let's go back. Now the fun begins, I promise. If you're just a user, you don't need to touch that Django server directory at all. What do you need to touch? The src source directory. So we're going to skip through tests. Like most Python-based projects, the main.py is the main entry point into using the code. So right now you need to navigate your shell into src source and follow these example commands in the README. Here's the command I'm talking about. So we're going to go back to this section. We already did the cloning. We already did the installation of requirements. And now we are going to go into source and run the main file. So go to source and then run main.py like so. If you're in doubt, of course, you can just mess up and it'll help you. Now, the 6 node minimum, I want to mention this. We've said 6 because as you see in our proposal document, terminology-wise, we have changed things over time. So client is originator, the server is the recipient. So Alice and Bob. Now you got guys in the middle, you got these guys. In the middle of the cycle is intermediates. And you don't want too few of those guys, otherwise you lose the concept and the protection of the cycle. This is why I currently am setting up 6 individual bash terminals to simulate 6 different users. You can probably do this more efficiently and repeatably with a tool like tmux, but I'm not going to mux around with that right now. Notice how I'm setting a different port for each simulated guy, because I'm just one computer, so I got a limited number of ports. In reality, on different computers, you might just all use the same port. We've set 53,600 as the default. CS536. I also got to be careful because all 6 guys are currently sharing my same directory. So let me use that -d flag and initialize one of these guys in a different directory. As we'll see, you can send a file from anywhere, but you can only receive in this starting directory that's specified. This is because otherwise, someone can send and overwrite any file elsewhere on your computer. I just patched that security bug, so don't worry. First, we're going to run it without diagnostic mode, the big D. So let's go and see that slick intro message. Now in our README, let's look at this file sharing app and its 3 commands. So in this section of the README, we have usage for the file sharing app. We've already started the node here, and now we're going to go and look at these 3 simple commands. The first, list, is easy to comprehend because you already use a shell. You just list, and then you put another user's name. Send is intuitive. You've got a file, and you want to send it to someone else. I got to be careful in the demo, though, because we're all on the same computer. Now receive. This is when you've already listed someone and you think, oh, requirements.txt, I want that file. And then you just receive it from that guy. So here's the guy and here's the file name. And that's pretty much it. Now let's fire up diagnostic/demo mode to see what's happening underneath. And while we're here, let's look at some known issues. The list server as a centralized source of info approach has its limitations. The list server can only refresh so fast, so note here how the names aren't wiped immediately when we log off. So we need to wait a minute for the list server to catch up. Same thing happens if you log on and then immediately try to list someone who just logged on. The list server is going to say, who? But anyway, take a look at these gray messages. This is what's happening underneath. Remember the Shallot cycle? Here it is. On our Alice, our originator, whose actual name is first. Our Bob, our recipient, is second. Now look at the intermediate guys. They can know who sent it to them, and they can name who they sent it to actually as well. However, they have no analysis that can tell them whether the previous guy was the originator, Alice, or if the next guy is the recipient, Bob. Note because I'm running this on one computer, diagnostic mode isn't able to use IP address to name everyone on the receiving end due to sending out random ephemeral ports. But in reality, when everyone has their own computer and IP address, diagnostic mode can show you that. And thank you. That's all I got for the demo. I kind of want to make another video going through each of the files and explaining them. I've got the script, but I'm out of time for now. So please have fun with Shallot routing with your friends, and feel free to contribute as well. Take a look at the bottom of our GitHub page for some instructions on contributing. Thank you and have a nice day.